In this operations management tutorial, we're going to look at material requirements planning, or MRP, and manufacturing resource planning, or MRP2. My students can access the video tutorials for these problems using the content menu in D2L. YouTube viewers can access the video tutorials on my MOOC on udemy.com. I have a long and short version of the URL posted on the screen, and I will post this URL in the description. Let me just give you a heads up about MRP calculations. They're fairly easy and straightforward, but they're hard to pick up on your own. Getting them right and keeping everything straight keeps practice. Let me strongly encourage you to watch the video tutorials I just mentioned. Shown on the screen is an overview of a good bit of your operations management course. Forecast drives aggregate planning. Aggregate planning drives the master production schedule. The master production schedule is checked by rough cut capacity planning, which only looks at critical workstations. If there's an issue, you go back and either change the aggregate plan or change the master schedule. The master production schedule then drives material requirements planning, which is what we're going to talk about. The MRP plan is checked by capacity resource planning. If it finds an issue, you either change the master production schedule or the aggregate plan. MRP then drives shop floor scheduling and purchasing. Material requirements planning is defined as a computer-based information system that translates master schedule requirements for end items and time-phase requirements for subassemblies, components, and raw materials. MRP was a precursor to enterprise resource planning, and MRP was introduced in the 1970s. When MRP was introduced, it ran on mainframe computers like the one you see on the screen. These mainframe computers would cost millions of dollars, and then they had additional costs for the computer room to put them in and the operators to run them. That means that companies got more than those costs, more than those millions of dollars in value from the MRP software. We've talked about this several times before, but dependent demand is demand for items that are subassemblies or component parts used in production of finished goods. If you're a Ford Motor Company, these are engine transmissions and tires. You might make these the way Ford makes engines and transmissions, or you might buy them the way that Ford buys tires. Once the independent demand is known, and we know it through forecasting, the dependent demand can be determined or calculated using MRP. Dependent demand tends to be sporadic or lumpy. We need a bunch of the item on hand when we start production. We don't need any on hand when we're not doing the production. And here we're primarily talking about job shops, not assembly lines. What this means is that large quantities are used at specific points in time when we're producing, with little or no usage at other times when we're not producing. MRP is most valuable in industries where a number of products are produced in batches using the same production equipment. In other words, a job shop. MRP does not work well for companies that produce a low number of units annually, because it's just not worth the energy to do the planning. This is especially the case for companies producing complex, expensive products requiring advanced research. These companies are often better served using project management approaches. There are three major inputs to MRP. 1. The master production schedule. This is the schedule of independent demand items that you're going to produce and when you're going to produce them. 2. The bill of material, what it takes to make your independent demand items. And 3. Your inventory records. We'll talk more in detail about each one of these. The master schedule, sometimes called the master production schedule, states which end items are to be produced, when they're needed, and on what quantities we need them. So it's a period-by-period statement of what we're going to make. Those periods are called time buckets. Time buckets separate the planning horizon into a series of time periods. These are almost always weeks. They don't have to be, but they almost always are weeks. An important concept in MRP is cumulative lead time. Cumulative lead time is defined as the sum of the lead times that sequentially phases the production process from ordering of parts and raw materials to completion of the final assembly. In other words, how long does it take to order the parts for the transmission? How long does it take to make the transmission that goes into the car? And how long does it take to make the car? In a job shop, this would include the move time between work centers and the time that the production has to wait at the work center before they can start working on it. We've talked about the bill of material, or BOM, before. It's a listing of all the raw materials, parts, subassemblies, and assemblies needed to produce one unit of a product. In order to plan how to make a product, we have to know what we need to make that product. A product structure file provides a visual description of the subassemblies and components needed to assemble a product. It's just a way of presenting a bill of material. On the screen, you see what's called an indented bill of material. Indented bill of materials are common in the factory floor because they're all text, and so any printer can print them. Each level is indented below its associated higher level. So here we're showing a car is made up of an engine, a transmission, and tires. Then under engine, we've got the block and the pistons. Under transmissions, we've got the case and the gears. You can also see over on the right that it shows the quantity. This is typically the way a bill of material is presented on the shop floor. Here you see a product structure tree for the end item X. X is the end item, so it's a level 0 item. Each X is made up of 2 B's and a C. An X is made up of 3 D's and an E. A C is made up of 2 E's and 2 F's. And a D is made up of 4 E's. Low-level coding restructures the bill of material so that multiple occurrences of a component all coincide at the lowest level at which the component occurs. This simplifies our MRP calculations. So if you think back to the prior product structure tree that I showed you, we have E's on level 2 and level 3. You can't move items up, so we would move all the E's down to level 3. That's all it is. MRP records are made up of gross requirements, scheduled receipts, amount on hand, lead time, lot sizes, and a lot more. We'll talk about each one of these. Gross requirements are the total expected demand that we're planning for. This comes out of the aggregate plan through the master production schedule. Scheduled receipts are open orders scheduled to arrive but which haven't arrived yet. We're not planning for them, they're just going to show up on the receiving dock. Planned on hand is the expected inventory on hand at the beginning of each period, although some textbooks use the end of the period rather than the beginning of the period, so you have to pay attention to what your textbook does. Material requirements planning translates the master production schedule into time-phased production and purchases. Basically, MRP calculates the demand for dependent demand items along with the time that we need to place those orders or schedule that production in order for them to arrive on time. This helps to lower our inventory requirements, basically our inventory on hand, by only receiving or producing things when we need them. MRP can also easily be used to replan when things break or material is not received so we can't produce what we originally planned to produce. MRP processing takes the end item requirements specified by the master production schedule, the things that we're going to sell to our customers. It then explodes them into time-phase requirements for assemblies, parts, and raw materials. That is, it uses the bill of material offset by lead time to figure out when to schedule orders and production. These quantities generated by exploding the bill of material are gross requirements. They don't consider what we have on hand already, in other words, what we have in inventory, and they don't consider any shipments that are going to be received, scheduled receipts, for example. The quantities actually needed to meet demand are what we call net requirements. Net requirements are the actual amount needed in each time period for each item that we're planning. Planned order receipts are the quantities expected to be received at the beginning of the period. This could be net requirements, or it could be net requirements adjusted for lot sizing. These are offset by lead times to develop planned order releases. These are the planned amounts to order at each time period, whether we're ordering it from ourselves in the production floor if we make it ourselves, or we're ordering it from the vendor if we buy it. Shown on the screen is the MRP planning grid that I use in the video tutorials. It's a little bit more complicated and color-coded, and you won't see that in a textbook. It also has 2 projected on hands, and almost all textbooks only show 1. That's because some use the beginning of the period, some use the end of the period, so I show both. The gray areas aren't used at all. Data only comes into the grid on the yellow area. The blue area are interim calculations. In other words, once you get the answer, you could erase them. I mean, don't do that. Your instructor might want them, but you don't need them after you've done the calculations. And data only leaves the grid from the orange area. In other words, it's only the numbers in the orange area that flow into another planning grid. Oftentimes, the same parts are used in multiple products. Screws are used in a lot of different products at a company, for example. We have to combine all these uses into one order when we're developing our MRP plan. Now let's talk about safety stock, a topic we've talked about several times already. Safety stock is extra inventory that you hold just for emergencies. You don't expect to use it in normal operations. There are 2 ways to include safety stock in MRP calculations, but the most common way is to subtract it from your inventory balance before starting the problem. After that, safety stock does not affect working the problem at all. That is the approach that I show in the video tutorials. The other way is to leave it in the inventory and just never allow the projected on hand to drop below the safety stock level. Allocated inventory is inventory that is promised so it's unavailable to production. So you've promised it to engineering, to a customer for a special order, or for whatever reason you just can't use it for your production process. That means for MRP planning, we have to treat it as though it does not exist. The way we do that is to subtract it from the inventory balance before starting the problem, just like safety stock. After that, it does not affect the problem at all. Just like safety stock, a few textbooks will handle it by never allowing the projected on hand to drop down below the allocated level, but that's not very common. Sometimes customers will order what we consider to be a dependent demand item. For example, a Ford customer ordering a new engine. We don't normally include these in the master production schedule. Now, if it became a regular item with lots of orders, we might do that, but we don't normally do it. Instead, they are fed directly into the material requirements planning program at the appropriate levels. That is, we just add on the gross requirements. Pegging is a very useful MRP tool. Pegging is the process of identifying the parent items that have generated a given set of material requirements for an item. This allows planners to see what products are affected due to delivery problems. For example, you ordered some bolts and those bolts are delayed. Pegging allows you to see what end items that you're going to produce that are going to be affected by the bolt delay. It can be especially useful when lot sizing is causing a problem. So you always order the bolts in lots of 1,000, but you only get 250 this time. Is that going to cause you a problem? A pegging report will help you determine that. There are two ways of updating your MRP system, regenerative and net change. A regenerative system updates the MRP records periodically. It's best suited to fairly stable systems and is far and away the most common. A net change system updates MRP records continuously. It's like a spreadsheet. Anytime you change one number, all the numbers update. So every time you have a change, that change is exploded throughout the system. We would use this with a system that had frequent changes in requirements. Let's talk about the MRP primary reports. There are 3 of them. The first is planned orders. That's a schedule indicating the amount and timing of future orders, either from a vendor or your production floor. Order releases are authorizations for the execution of the planned orders. And changes are revisions of due dates or order quantities or cancellations of orders. Let's briefly mention 3 secondary MRP reports. The first is performance control reports. These evaluate the system performance, the production system, not the MRP system. The second is a planning report used to forecast inventory requirements. The third are exception reports, and these call attention to major discrepancies in the production process. Let's loop back and talk about safety stock again. We always need safety stock for our independent demand items because we can't be certain what customers are going to order. Theoretically, the MRP system is efficient and we shouldn't need any safety stock below the independent demand item. This is the major advantage of MRP, only ordering exactly what we need when we need it, lowering our inventory holding cost, which is where the cost savings from MRP comes into play. However, there are exceptions: bottlenecks, variable scrap rates, and unreliable vendors. Unreliable vendors is probably the biggest one. So a variable scrap rate is you're making loaves of bread that you use to make sandwiches. You have to cut off the end pieces. Sometimes you might get 20 slices out of a loaf of bread. Sometimes you might only get 19 or 18 because you cut more of the end off. That's the variable scrap rate. Now let's talk about lot sizing. Lot sizing is choosing a lot size for ordering or production. In other words, deciding how many you're going to order or how many you're going to make when you order or make them. For independent demand items, we typically use an economic order quantity, EOQ. There are a variety of lot sizing techniques used for dependent demand items. The most common is lot for lot, which is a fancy way of saying order exactly what you need or buy exactly what you need. You can also use the economic order quantity. Another is fixed period ordering, which is where when you place an order, there's a certain number of periods you order for. So if it's 3, for example, when you place an order, you order enough to handle the next 3 periods, whatever that quantity is. Now let's briefly talk about MRP in services. It's not used a lot in services, but it can be used. It does have applications in services. It's typically used for the tangible items that form part of a service package. For example, if we're a caterer, we might use MRP to scope out the meals that we're going to make. So the recipe would be our bill of material, and the ingredients would be our dependent demand. So what are the benefits of MRP? The biggest one, and I've already talked about this, is low levels of inventory, both raw materials inventory and process inventory. The second is the ability to track material requirements. I've talked briefly about that. Another is the ability to evaluate capacity requirements, and I talk about that in the next lecture. Scheduling the production of our dependent demand items, the ones that we produce, gives us the way of allocating our production time. And we have the ability on an assembly line to monitor inventory using something called backflushing. So backflushing is when a car comes off the assembly line, for example. You know it's got an engine, a transmission, 4 tires, and lots of other things. So you can just take what's in that car and subtract it from inventory. You do this rather than tracking the inventory as you use it, and that's called backflushing. So what are the requirements to use MRP? They're exactly what you would guess they are. You need a computer and the necessary software. At one point, that was a big deal. At one point, people spent millions of dollars on the computers and the software. Now it runs on a high-end PC. We need accurate and up-to-date records. The master schedule, the bills of material, and the inventory records all have to be pristine in order for it to work. And we need to maintain data integrity. Once the data gets corrupted, all of the MRP planning is corrupted. Manufacturing resource planning is an expansion of MRP. It includes financial planning, marketing, engineering, purchasing, and manufacturing. Basically, MRP grew from the shop floor out into the organization. A formal definition of manufacturing resource planning is an expanded approach to production resources planning involving other areas of the firm in the planning process and enabling capacity requirements planning. If you enjoyed this video, please click like and consider subscribing to this channel.